in our mass-to-mass conversions today. So as I look here, my learning target once again is to calculate the actual yield of a reaction given the reactants. And today we're going to use, for our success criteria, we're going to use the molar ratio to convert from moles of one substance to moles of another. That's nothing new. We just did that on that entrance slip. And the new part is we're going to calculate the mass of a product given the mass of a reactant. So this is what we call mass-to-mass reactions. Here is our very first example. So go ahead and copy this into your notes. The question states, what is the mass of lithium? What mass of lithium is required to produce 0.915 grams of lithium nitride? The other reactant is nitrogen. Now, this is really nice because they give you everything that you need for this particular equation. Now, when you watch the video, there were 7 different steps to perform one of these things. And the very first step in the mass-to-mass problem was to determine the reactants and products of the reaction. So we needed to write a skeleton equation. And it says, lithium reacts with nitrogen to produce lithium nitride. Now, I need to balance that chemical equation. So what I'm going to do is I'm going to start with balancing up my nitrogen. And that will give me 6 lithium there. So the second step was to balance the equation. The third step was to determine what is my known. And my known is that 0.915 grams of lithium nitride. So I've determined my known. I need to determine what I am trying to find. So, what mass of lithium? So my known is 0.915 grams of lithium nitride. What I'm trying to find is my mass of lithium. Now I need to convert the substance to moles. So I look here and I say, okay, I have 0.915 grams of lithium nitride, correct? I need to convert that to moles. Now, ladies and gentlemen, that is a flux capacitor step. It has nothing to do with the balanced chemical equation. That is the next step. Okay? So, this step right here, I'm going to convert, set up a conversion box, and I'm going to convert this into moles. Now, I know on my flux capacitor that 1 mole of lithium-3 nitride has a mass, a molar mass of 34.8297 grams of lithium nitride. Now, where did I get that number? Well, I multiplied 3 lithiums, okay? The mass of lithium is 6.941. I multiplied that by 3, and then added to it the mass of nitrogen, the 14.0067. So, when I do my canceling, I've now converted this into moles of lithium nitride. Now, one of the most common things, folks, that I see right here instead of saying 1 mole of lithium, people come over and say, in my balanced equation, I have a 6 there. So they put a 6 moles of lithium. Would that be a true statement that 6 moles of lithium equals 34.8297? No, because that is 1 mole. Don't make that mistake. I see that quite often. Now, my next step is to convert from moles of my known to moles of my unknown using my molar ratio. So here's where that molar ratio comes into play. So I'm going to extend my conversion box again. And I look and I have on the top here lithium nitride. So I'm going to put 2 mole of lithium nitride on the bottom there because I want it to cancel. What am I trying to find? Lithium. So I'm going to go 6 mole of lithium. My labels cancel right there. So now I've converted this into what? Moles of lithium, right? My final step is to convert from moles of the unknown substance to a mass of the unknown substance. So I'm going to put another box out here. Okay. And I want my moles of lithium to cancel. So 1 mole of lithium has a mass of what? 6.941. Where did I get that value from? The mass of lithium on the periodic table, right? So my mole of lithium cancels, my mole of lithium cancels. I've got my work set up for this problem. My label is going to be grams of lithium. That's what I was trying to find. So I get my calculator and I take 0.915. I divide it by 34.8297. Multiply by 6, divide it by 2, finally multiply it by 6.941, and I come up with a value having 3 significant figures, 0.547. So what does this tell me? Well, if it tells me that if I want to produce 0.915 grams of lithium nitride, I need to start with 0.547 grams of lithium. Does it say anything about my other reactant? No. Could I go back and calculate how much of that I needed? Absolutely. Okay, but I wasn't asked to do that. Any questions here? Now, remember that this step and this step are flux capacitor mass to moles. The middle step is the molar ratio, like we did yesterday on our entrance slip. Here is our next example. Go ahead and copy it down. It's a long one. My question states, iron 3 chloride reacts with sodium carbonate to form iron 3 carbonate and sodium chloride. Looks to me like a double replacement reaction. So I need to write out my skeleton equation to start with. So I have FeCl3 will react with sodium carbonate it's going to yield iron 3 carbonate, and sodium chloride. Now, when I go through and balance that, I can see probably what I'm going to do first is I'm going to balance up my, actually that is not correct, because I need a 3 right here. So I'm going to balance up my carbonates first. So I balance up my carbonates. That gives me 6 sodiums. So I'm going to put a 6 there. If I put a 2 here, that balances up my equation. So can you see how this is kind of the coverall? We've already written down formulas for the names. We just wrote a skeleton equation that was a double replacement reaction. We just balanced that double replacement reaction. Now we're going to start into the math of the problem. Okay? What is known? Well, I know that I have 0.700 grams of sodium carbonate. What am I trying to find? I'm trying to find a mass of iron 3 chloride. So those are both dealing with my reactants. So I look and I say, okay, I have 0.700 grams of Na2CO3. My very first step is to flux capacitor that into moles. So I need to have the molar mass. Well, I've already calculated the molar mass. I know that it is 105.9888 grams of sodium carbonate, and that is 1 mole of sodium carbonate. So I get my grams to cancel. I've now converted that into moles of sodium carbonate. I'm going to look at my molar ratio now. So I look, and what do I want on the bottom? Moles of sodium carbonate. So I have 3 moles of sodium carbonate. I'm going to iron 3 chloride. So I'm going to have 2 moles of FeCl3. Where did I get the 3 and the 2? Right there, my molar ratio in my balanced chemical equation. So, my moles of sodium carbonate now cancel. My final step is to convert from moles of my unknown to grams. So this, once again, folks, this is a flux capacitor move. So I know that I have 1 mole of FeCl3, 1 mole of iron 3 chloride. What is that mass going to be? Well, if I take 3 chlorines and 1 iron, I come up with 162.195 grams of FeCl3. So my moles cancel. My label now is going to be in grams of FeCl3. So all I need to do now is just go through and work my math, starting with 0.700. Note there are 3 sig figs there. I divide by 105.9888. 9888, multiply by 2, divide by 3, multiply by 162.195. I come up with a value of, with 3 significant figures, 0.714. So if I have 0.700 grams of sodium carbonate, that will react with 0.714 grams of iron-3 chloride. The exact amount. We okay with that so far? Now, here is my second part of this particular one. It says, what mass of sodium chloride will be produced in the reaction? Now, I've copied the balanced equation again there, so I didn't have to go back up there. I always use the value that was given to me. Okay? So could I use the 0.714 grams of iron-3 chloride? Yeah. Okay? I'm not going to use that, though. I'm going to use what was given to me. And what was given to me was that 0.700 grams of Na2CO3. Now, once again, I'm going to set up my conversion box, and I have a big, long one here because I'm going to have to do a few steps again. This very first step is going to be the same one as what I did on the problem above. 1 mole of Na2CO3 is going to give me a mass of 105.9888 grams. So that step is the very same as it was just above. Now here's where I go different because I'm converting it to a different substance. I'm trying to find sodium chloride. So on top, I'm going to put 6 mole of sodium chloride. On bottom, I'm going to put the 3 mole of sodium carbonate. My moles of sodium carbonate cancel. So now I've converted this into moles of sodium chloride. My final step is going back to a mass. So I have 1 mole of NaCl, sodium chloride. That's going to have a mass of 58.4398 grams of sodium chloride. My moles of sodium chloride cancel. So now my label is going to be grams of sodium chloride. All I have to do is my math. So I take 0.700 divided by 105.9888, multiply by 6, divided by 3, multiply by 58.4398, and I get a value with 1, 2, 3 sig figs to be 0.772 grams of sodium chloride. So this tells me if I start with 0.700 grams of sodium carbonate, and I have 0.714 grams of iron-3 chloride, I will produce 0.772 grams of sodium chloride. Questions on that particular problem here? Okay. Now, the final thing. I'm going to let you do this one on your own. Okay, but I'm going to stop you to make sure we have the correct balanced equation. So what I want you to do is I want you to copy down the example, and I want you to balance the equation. Once you've done that, stop. We'll make sure we have the correct balanced equation, then I'll let you go on. Here is the example. Okay, we're going to start by balancing this equation. I saw some really good things because I saw some folks pulling out their reaction prediction packet. Because what type of a reaction is this? A combustion reaction. So I'm going to take C6H6, and it's going to react with oxygen. And what are my products of all combustion reactions? Carbon dioxide and water. So I need to balance this out, okay? And I look, and I'm going to start, I always start with my carbons, okay? So I'm going to start with my carbons, and actually, I'm just going to balance it for you because I know what it is. I've already done it. I'm going to need 2 carbons there, which is going to give me 12 carbons there. That gives me 12 hydrogens, so I'm going to need a 6 there, and to balance everything out, I'm going to need a 15 there. So I now have my balanced chemical equation. What I want you to do, ladies and gentlemen, is I want you to solve this problem. Once you have it solved, bring it up to me so I can make sure that you did it correctly.